Okay, let's get started. So on the menu today is lecture number 7, is the exceptions and I/O handling, or I/O, excuse me, I/O facilities and exception handling all into one. Theme for today. I believe we are more than halfway through the course, actually, at this point. So should hopefully be doing some of the assignments, getting ready for the end of the term. Don't have the exact dates yet for the final exam, but I'm thinking it's going to be the end of November, first part of December, perhaps maybe the first week in December. Yes? Middle of December? Could be. Oh, probably. What did you say?
The calendar says that it is.
Oh, the calendar. When does the calendar say?
Second week of December.
Oh, second week of December. Okay, that works too. Second week of December. Like I was saying, I don't know exactly. I'm not familiar exactly with the calendar right now. I'm saying that we're looking at maybe, because this is like the middle of October, so we have another month and a half maybe, is what I guess that's what I'm trying to say. So we're about halfway, we're more than halfway through, we have about a month and a half left. We have some holidays coming up, so, like a Thanksgiving holiday, we're probably going to miss one. I don't know if we have class on Wednesday before Thanksgiving, but I guess we'll find out. You're shaking your head no? Or is this yes? No. You really mean no. There's no class on Wednesday before Thanksgiving? Hopefully there isn't.
But the holiday won't affect because
Well, a lot of people travel for Thanksgiving, though. Usually most companies have their Wednesday off the day before because people have to travel. I guess I'll confirm with that. I'll confirm that back with you as well, along with everything else I've been talking about. So since this lecture started, I will confirm next time. So let me get back to something I know what I'm talking about, hopefully. Overview. Here's an overview of the exception hierarchy. So unlike other languages, some other languages support this concept as well, but Java in particular has a really good job of handling exceptions. Oh, you know what? Going back to what I was originally saying, because this is the Java object-oriented programming class, there was a reason why I was mentioning the final exam. I'm giving it for the weekend section on the 29th and 30th of October, which is another week or so down the road. It's about 2 weeks, maybe, week and a half over. So it's not this coming up weekend, it's the following weekend. So if you would like, you can take the final exam early if you want. The advantages you have of taking it on the 29th and 30th, if you'd like, you don't have to, is that there won't be any programming. It'll be multiple choice and short answer. The exam that you're going to get in December-ish will have some small programming on it. Not very much, though. And it'll be a slightly different exam. The reason why your exam, if you take it on the 29th, 30th, is going to be of a slightly different format is because the weekend class, the duration of that class was only a month and a half. And so they're still working on the assignments. They're not quite done with the assignments yet. So it's going to be more theory. It's going to be a different type of exam. It's going to be more theory-based versus practical implementation-based or skill-based. So if you prefer the theory-based, some people don't. So I've given them the option of taking your exam, and I'm giving you guys the option of taking their exam. So I just wanted to let you know. It's another week away. It's on the 29th and 30th weekend. You're more than welcome to show up anytime you want from 10 o'clock in the morning till 4 o'clock in the afternoon. Well, maybe by 3 would be good to show up. October 29th and 30th, Halloween weekend. Either Saturday or Sunday, it'll be offered from, I want to say 10 to 3, just to be safe. Show up between 10 o'clock in the morning and 3 o'clock in the afternoon. You don't have to tell me when you're going to show up. You don't even have to tell me. All you have to do is write on your top of your exam, weekday student, and then I know to fit you in with the weekday. But it's an option you have. It's a different type of exam, so people who don't like to do the hands-on programming part of it and want to answer theory questions, that's a choice that you have. So, 2 different styles. Some people prefer one or the other. So, any questions before I actually start this lecture? All right, so those of you who came in late, exceptions in I/O. Now I'm going to start the lecture. All right, here's a simplified diagram you've been looking at, hopefully, regarding the exception hierarchy in Java. We have an object above, the main object throwable. It's going to throw a couple things. It's going to throw either an error or an exception. Believe it or not, they are 2 separate things. In some programming language interfaces, they're considered the same. The difference here is the error can actually execute essentially a stop or a break in the program execution. An exception might be thrown, and depending upon what the nature of the exception is, we can have exception handling to essentially, throw some sort of activity that might occur. The activity might fix it. The program may not necessarily exit as it would in an error condition. And an error condition is more serious. There's not very much we can do with an error. An error is generally something that's missing, an illegal instruction call, a problem with the JVM, a problem with a security issue or something. Not very recoverable. So this side over here, the exception side, is a little bit more recoverable. As an example, if it threw an I/O exception, it meant perhaps it couldn't find a file, couldn't open the file, couldn't read the file. So you might have another option choice in the flow control of the program to come back and say, well, pick a new file, or write it. If you can't write it, try a different location, or some backup plan or something. So all of the exceptions extend the class throwable. That's the class throwable up there, which immediately splits into two branches, the errors and the exceptions, as we're looking at in the diagram here. And we might have to shut that back door if it gets too loud. I don't know. I guess not. It's just people walking down the hallway. So the error, internal errors, and resource exhaustion. Yes, resources can actually get exhausted inside of the Java runtime environment. There's very little you can do, as I mentioned, with that. And when I say resources that get exhausted, it could be runaway, endless loop type of classes or methods that are causing a situation where the garbage collection isn't working correctly, and then we're running out of memory. Or it could be a case in which we have too many objects are simultaneously loaded for something, and it's causing everything to run slowly or something. That's not going to give it an error. An error is going to be a problem, usually with a JVM. And the JVM is going to pick it up. It's going to be some sort of a runtime error. And usually when you see the message, it says runtime error, a number, and something like that. That is different than an exception. Exceptions splits further into two different branches, as we've seen here, I/O exceptions and then runtime exceptions. I/O essentially is the reading and input and the output of files, of streams, of data, of keyboard input, of buffered variables, things of that nature. Could cause an I/O exception. The runtime exception is going to be everything else, which is kind of interesting why they broke it out into those two different categories. But if you think about the logic, it's either you're trying to use an external resource to the program to do I/O, or it's the runtime environment usually. And the runtime environment is kind of interesting because some of the things that fall into that category you wouldn't think would be runtime. Like a missing method or something. That's more like an error or something, or a missing class, or something of that nature. So the focus is on the exception branch itself, the two branches of the exceptions. So exceptions that are derived from runtime exception, and you have to think in the hierarchy of all the objects in the object-oriented environment. We have a ton under here. In fact, we probably have more under here on the runtime end of it than we do on the I/O end of it. So the chart's not showing you everything, it's just showing you the top level. And this is coming from object. It's going to be throwable, and then exception, and then runtime exception. So some examples of the runtime exception are going to be, and then here's what I'm going back to, is it really a runtime or is it really an error? Like an array being out of bounds, or out of array access, a bad cast. These are sort of things that in C++, if you wrote past the boundaries of an array, you're not going to get a runtime exception because it's the Windows environment that's controlling it, not the JVM. So it's the JVM that is essentially saying, hey, there's something wrong with the logic of your program, and the JVM is the runtime. So the exception that's thrown is basically a heads up to you to say, you might be writing past the bounds of your array or something. So it's usually array out of bounds error exception that actually comes up with that. Happens because errors exist in your program, your fault. Well, yes and no. It could not. It could be the problem that, let's say, for example, you're making an instance of an object and the object it doesn't exist or something. Well, it could be your fault, but it might be that the object went out of scope or the object was deleted off the server or something in a networking environment. So those not in the type runtime exception example, trying to open a malfunctioned URL has gone away, which is going to be a sort of not your fault type of thing. Or program is good, but other things happen. Stuff gets messed up in the JVM. Those would also be considered runtime exceptions. So they all fall into that blanket category. We have checked versus unchecked exceptions, for which is why we're doing this exception handling is obviously going to be the checked route. The unchecked ones are derived from a class error or from the class runtime exception. And so they're generated because we're looking for them. And the checked exceptions, these are unchecked exceptions. They come from an error or from a situation that has caused a runtime issue for which we haven't been looking for. We can check them. Are all the exceptions not included in the unchecked? So if they occur, they must be dealt with in some way. So when we do an exception handler and we look for a particular exception, we're saying when this happens, if this happens, do this. Try this file instead of that file, or switch the URL to this other URL, and maybe have a list of URLs it goes through or something like that, or some issue that's perhaps a recoverable situation. The unchecked exceptions we don't have exception handlers for. They just happen, and we deal with them when they happen. So generally the program stops running or something of that sort. So the compiler will check whether or not you have provided an exception handler for checked exceptions which may occur. No, in lack of an exception handler, it's not going to be handled, obviously. It's not going to be checked. So how do we invoke an exception handler in Java, which is the interesting part of this lecture? So we can declare a throws, so we can throw a checked exception, and the keyword is throw, which is interesting. So it's kind of user intuitive if you think about it. Java method or constructor should be declared to throw an exception under two situations. One, if it calls another method that throws an unchecked exception. So we have an unchecked exception. We use it as a blanket category to say throw an exception, and it's going to essentially catch anything that is unchecked in a kind of a generic category. Or it throws a checked exception with the throw statement inside the body and actually throws an exception. Here's a couple of examples down here I'm going to go through in a few minutes. So declare a method or constructor to throw an exception or exceptions, one or more, using the throws clause, is in the header of the method. So here we have a single exception, public file stream, input file stream, file input stream, dyslexic today, throws file not found exception, which means we're looking for a file not found exception. If it's thrown, then we're going to obviously, hey, you tell the user, hey, this is a bad file name, we can't open it, or we can't close it, or we can't do something with it. And then the multiple ones, well, you just separate them by commas. So these are the throws end of file exception or IO exception. And you separate them by commas. You can put as many as you want on there. There's no limit. So you can throw all of the exceptions. The only thing is, you don't want to get an entire list of these, and there's half a dozen or so, and then throw them all, because some of them might be unnecessary in some cases. If we're not opening up a file, we probably don't need to do the IO exception. So you should not declare an unchecked exception after throws, because after throws is going to be in the blanket category of the throws. They are either going to be outside of your control, or it should be avoided completely by correcting your code, hopefully. You don't necessarily want to throw exceptions by nature, but it's like the backup plan. It's like for when you think there might be an exception, but you don't want to put the code in there to check for it. So you throw the exception. It's kind of like the template they usually give you for I/O importing, file I/O in C or C++, where you do a try and a catch. You try to open it. If not, catch this. And the catch is, hey, the file's bad. The file doesn't exist, or something of that nature. So using the throws to throw an exception to continue the concept, it can throw an exception under some bad situations. Here's an example. A method named readData is reading a file whose header says it contains 700 characters, but it encounters a file that only has 200 characters, so it's short by 500 characters. You decide to throw an exception when this bad situation happens by using the throw statement, and here's an example. By running the method throw new end of file exception, so you're explicitly throwing it. or saying creating an object E, which is going to be of type end of file exception. So end of file exception E is equal to new end of file exception. Same way as we create other new objects, instances of objects, we would create an instance of this particular object that we're throwing called end of file exception, and we throw E, which means we're referencing throw to this E. We're making it, throw this object, and this object is the E end of file exception instance that we created for that particular new object. So the entire method would look like this. Here we have the string read data. The scanner in class is essentially just the method, the object, the in object of the scanner object, instance of the scanner object that's going to be used to take the buffered I/O in from the keyboard, or from, not from the keyboard, from a file. And the key here is we're going to say it throws an end of file exception inside of it while something, if it doesn't have next, if that's encountered, if there's no next element, we're going to end up hitting the end of file. If that happens, then throw this here, this new end of file exception, which is essentially going to be handled. So at the end of the file, where your file only has 200 characters when we thought it had 700 characters. Your file is too short or something. Or your file is too big, or depending upon what you're throwing. So the throw is used, and I'm going to have some catches coming up soon so you can see how the exception handle actually looks. So using throws to throw an exception, to continue with the example, in the method body, you can only throw exceptions which are the same type or the subtype of the exceptions declared after throws in the method header. This has been in the method header, end of file exception. You can throw any of the end of file exception subcategories, subobjects in here, inside of the body of the method. If you find an appropriate exception class in the library, make an object of the class and then throw it, which is what we've kind of looked at. Otherwise, you design your own exception class, which is entirely possible. If you're designing your own exception class, you're using inheritance, like we've seen before. Just like you've inherited from objects that you created yourself by using extends. In this particular example, we have a no such attribute exception, which extends exception. By extending the exception class object, you're creating your own implementation, your own specification, or a specific type of an exception. So you can create your own exception handle, exceptions that you're going to be throwing. So to create a new exception type, exceptions are objects, new object types which extend exception, or one of the subclasses. You don't have to extend. You can actually extend I/O exception if you wanted to, and maybe overload the message that gets printed to the screen. Maybe you don't like the error messages. Maybe you don't like, what would naturally be printed out, or you want to change the wording or something of that nature. You just throw it, and then extend I/O exception, and then overload one of the constructors, essentially, of that object. When the object is created, it's created upon an exception that has been thrown. Why create new extension types? Describe the exceptional condition in more details, as I just mentioned a few minutes ago in my simple example. And then just a string. So you can even put like a whole paragraph of stuff down there. You're going to get a simple string. In fact, most of the I/O exceptions you can probably find yourself by write a Java program that opens a file and then take the file away, remove the file. Usually you see runtime error, I/O exception, and then you see colon. It's usually one line that says bad file name, or can't open file, or locked file, or whatever happens to be the situation. It doesn't really tell you very much. So instead you can say, C database administrator, or you can add something in there, essentially, is what you're doing. And here we go. Here's our example. Suppose there's a method to update the current value of a named attribute of an object, but the object may not contain such an attribute currently. So we want an exception to be thrown to indicate that this particular event has occurred. So no such attribute extension here is going to extend exception. And we have a public class string attribute name. We're going to keep track of the attribute name. And then we're going to say no such attribute exception. This is our constructor. string name. It's going to send the name essentially to it. And then it's going to print out from super, which is an overloading exception, which means it's going to go back to the constructor for the exception class object. And in there, it's going to pass it the name of the string. And then it's going to say, because we're supering back to that previous exception, no attribute name, and then now it's going to print out the name of the attribute. And an attribute essentially keep track of the attribute that was actually not available for the update when the particular exception occurred. So then you can say, you can take that and actually send it back, use it to print something to the screen that says, you have to save the file before you can, or you have to set your property before you can change your property or something, or you have to, because the logic essentially was messed up. So you can probably see from this small little example here, hopefully, the power of this. In fact, you can't really do this in C++ very well. Not as easy. You can't just extend an exception class and add your own information and essentially configure it yourself. So the type of the exception is an important part of the exception data as well. Programmers need to do some actions exclusively to one particular type of exception or condition, not others. So you have to be able to make sure you can particularly work with particular exceptions, I meant to say, that get thrown. So let's talk a little bit about catching the exceptions. We can throw them, hopefully. We can override them and extend them. And when we create a new one, we can actually throw this no such attribute extension object when we're using it in a program. So checked exception handling is strictly enforced. So if you invoke a method that lists a checked exception in its throws clause, you have three choices to deal with. You can catch the exception and handle it, which is preferred method. Why are you going to throw it if you're not going to catch it? Declare the exception in your own throws clause, and then let the exception pass through your method. Or you may have a finally clause to clean up things. And I'm going to show you an example of the finally in a few minutes. But the finally clause is going to be used as a kind of a cleanup. Let's put things back. Let's open up a new instance of this object or something, or let's go to a different place in the program execution. So to catch the exception and map it into one of your exceptions by throwing the exception, you're to declare your own throws clause. Is another example. Here we have we're going to throw our own clause using a try-catch clause. So basic syntax of the try-catch. This should look familiar if you are familiar with C++ or C. This is what they drill into you. Do a try, then do a catch. Do a try, then do a catch. And what you're doing is you're trying some statements. So you put the same. If you're not familiar, don't worry about it. I'm going to explain it to you. The keyword try says, try this out. Open this file. Do whatever it is. And we're going to put the code that's going to generate the exception in the try. And then we have opening and closing brackets. It's kind of like the if-else and if-then kind of concept. Catch this, or catch this, or catch this, or catch this. But catch is a keyword that says, catch. Okay, can't catch it. Catch that one. Okay, can't catch it. We don't have to go if-else, because sometimes I see people putting in if this one, then catch this one. If that one, if this happens, or if x is less than 0, catch this one. Which you can still put in, actually. The compiler's not going to complain about that. But in the simplest form, we're catching the exception type. And the parameter is going to be, as an example, attribute. What did it say? Attribute not found or something? Or no such attribute exception E or something that's going to be in here. So the name of the exception object that we're going to declare. And then in here we're going to have the handler for this particular type. And then this one's going to be another one. So maybe it was no such attribute, and the other one was you made a stupid error, idiot, or something. So you entered the wrong value or something, and then that would be another exception that would be thrown. So not used for flow control, used for exception handling, but it's very similar to a flow control kind of concept when it's implemented. If no exception occurs during the exception, during the statements in the try clause, it finishes successfully and all of the catch clauses are skipped. If something is thrown after a try, Then all the subsequent catches are evaluated. If the catch actually exists, if it can catch it, if the object actually exists, then then the option for the catch will execute. Otherwise, it goes down to the bottom, goes through the entire structure. So you can have a situation in which you have an exception that's being thrown, but you're not catching it because you didn't specify it. As in this particular code example. So if any of the code inside the try throws an exception, either direct via the throw or indirectly by the method invoked inside of it, because you can do it at both levels, the program skips the remainder of the code in the try. It stops the try. It doesn't actually go through the end of it. Catches the clause and examines them one by one to see if whether or not any of the throw condition objects is comparable with the type declared in the catch. If it is, then it uses it. If not, then it skips it. And if the appropriate catch clause is found, the code inside the body gets executed and the remaining catch clauses are skipped, obviously. If no such a catch clause is found, that's really weird English in that blast. If no catch clause is found, nothing's going to happen. The exception is thrown into outer try that might have a catch clause or it might not. So, long story short, you can nest this. So you can have a try, and inside of the try have another try, and inside of that try have another try. If it's not found here, it's going to go back out to the outer, back out to the outer, back out to the outer recursively until it finds something. If it doesn't find anything, then it continues, essentially. It's not going to ever catch it. The catch clause with a subclass extension type cannot precede a catch clause with a super type. Can't precede a subclass extension type, because if you imagine the objects, if you have a more specific object, the one prior to it can't go before it. So you go down to the level of hierarchy to the bottom, to the subclass level. You go from the superclass level to the subclass level in level of detail. So each one of the object, if you're following that is an instance or is an object of, when you have subclasses in there, you have to make sure that you're actually catching the right behavior of the right object at the right level of the hierarchy. So here's an example actually to kind of put it in perspective. So we're going to have we're going to read a file in using a file stream, input stream. We're going to try input stream in is equal to new input stream on a file name. So if we give it a bad file name, we're going to have a problem. If the file name doesn't exist, we're going to have a problem. If the file is locked, can't open the file, we're going to have a problem. So the read method below is one of them that will throw an IO exception. And so we're going to have while b equals n.read. If it doesn't equal -1, process the input. This is not really running code, this is just kind of pseudocode. Otherwise, catch an IO exception E, and then we have exception print stack trace. The print stack trace is nothing more than it's going to be a method called a print it, which is going to be the ugly messages, which most people wouldn't do normally. They'd have something else print to the screen, like your file wasn't found, or something, instead of printing the entire trace. Another choice to design this for this particular situation is to do nothing but simply pass the exception onto the caller of the method. This I would call the C++ method, kind of the non-object oriented, do a try and do a catch, and a procedural type of, imperative language type of design. This is more of the object oriented approach, where we're actually going to throw an IO exception. We put it on the method call. So we have a public void read, throw IO exception, and then process the input, and then after the exception is thrown, we're going to do something with it. So if you call a method that throws a checked exception, you must either handle it or pass it on. We can look at the API to see all of the exceptions that can be thrown. In fact, I'm kind of interested if I click on this to see if I believe the link should still work. May not be working through my web browser, however. Whoops. Now that I clicked on it, it's either going to work or it's not going to work. Because my screen is not hosed. Let's see, 1 second. On slide 10. I believe well, my mouse is still working. I can't switch the page though. Huh. The internet is not working. Okay, that would probably probably the reason why I'm frozen right now and I can't escape out. Bad idea. But note to self, in the future, don't try to get web links when the internet's not working. Is the internet seriously not working? Alright, I have to, I'm going to have to reset my computer. I can't, it's frozen. Oh, cannot locate. Oh, good. Okay. I believe I'm still in business. Alright. This is a challenging day. Okay. Let me not click on any more links. We have the try and the catch clause. You're getting ready to go. I'm just kidding. You can go if you want. You're like, okay, class is over. Her computer froze. That's a lame excuse. Alright. No, but you may leave if you'd like. I know. Okay. Let's continue with this example without looking at any links on the internet because it's not going to work. That if you clicked on that link, if that link actually worked, just an FYI, I believe it will work. It's going to take you to the Oracle's website instead of the Java one for the documentation. And what you're going to see is about 20 or 30 different exceptions and different types. So you know what, we've looked at I/O as an example. We've got tons of other ones. End of file we looked at, but there's a ton of other different exceptions that you may throw. Nobody ever memorizes all the exceptions. You click on that link, you go to the website, and you find out what they are when you want to use them. So you can throw an exception in the catch clause. So typically you do this because you want to change the exception type to indicate the failure of this particular subsystem. Try access a database. Here's an interesting one that you would have seen at that website is SQL exception E, which means when we did a connect to the database or something, we have an SQL message that comes back that says that your command failed. We weren't able to connect. So throw an SE exception as an example, maybe short for SQL exception is going to be, or here's a servlet, maybe short for servlet extension for a database error. And then we can set the cause to E and then throw SE, which is essentially in our catch, we're throwing the exception. When we throw the exception, we're just going to get the runtime error message that shows to the screen because we haven't really done anything with it. When we throw in an exception at all, it just tells us, we're looking for this. When we see it, print all that stuff into the runtime environment. If we're looking at a DOS console, if we're looking at a GUI, we would actually have to, write it to an object or something. So when the exception is caught, the original exception can be retrieved. This chaining technique allows you to throw high-level exceptions in subsystems without losing levels of the original failure. So in an original failure, you can look for another failure inside of it, or another failure inside of that. So if we had an I/O exception, the I/O exception, if I had gone to that website, I would see I/O exception. Underneath it, I would see SQL exception. I would see a bunch of other different subtypes. So we would throw one, and we would throw another one. We would throw another one. All the subtypes is what I was basically trying to say. That's the order. You can't throw the subtype outside of the main type because it wouldn't actually know that there was a subtype at the main type object level. It's kind of like going back to the object-oriented hierarchy. If you're looking at let's say the hierarchy of people, and you said, well, we have people, person class, and then the person class we have an employee class, and then we have employees that are teachers, and we have employees that are janitors. If we ask the person class for the janitor's ID, well, it's not going to know it. So if we go back up to I/O exception and we ask for an SQL, it's not going to, oh, you're running SQL? Really? Seriously? It's not going to know anything about it. So basically you have to put the exception throw associated with the method that's going to be performing on a particular object at this particular object type, essentially, that might be actually thrown. And it's called chaining, by the way. So here's the keyword finally that shows up. You may want to do some actions whether or not the exception is thrown. That's what finally is for. It's kind of like the default on a case switch. At the bottom of a case switch in C++, we have default, which means something's going to happen if nothing happens. So at the bottom, at a finally clause, you're going to do this. And finally, what is finally going to do? It's either going to clean something up, print something out, or do something. So whether or not an exception is, an exception can be thrown or not thrown, and the finally is still going to execute. So it's not like the default in that, well, actually it is like the default if you don't break. If you break after each one of the cases, the default's never going to occur. But if you don't break and you have cases and then or you have catches, and the catches go, so will the finally at the end. So no exception is thrown. And here's our example. Graphics G is image like get graphics. Try 1, so the code that may throw an exception. 2, 3, here's an exception. 4, show some error message that might show up to the screen. 5, the finally is going to go. So no exception is thrown on 1, 2, 5, or 6. An exception is thrown and caught by the catch clause. So catch clause doesn't throw any other exceptions for 1, 3, 4, 5, 6. But the catch clause throws an exception at cell phone 1, 3, 5. The exception is thrown back to the caller of the method, and it can be dealt with from the caller of the method. An exception is also thrown but not caught on 1 and 5 as an example, and the exception is thrown back to the caller of this particular method. So 1 being up here, nothing's going to go. If the try doesn't work on the 1 case, we're not going to get any catches, we're not going to get any finally, we're not going to get anything. If we get a catch, we're going to get a finally. So we're going to get a 4 and 5 combination, we're going to get a 3 and a 5 combination. And on the clause that doesn't throw any exception, on the 1, 3, 4, 5, or 6, none of them is going to go because we're not going to get anything. It's just going to try and it's going to work. So, unless we have a failure on the try, none of the catches are going to work. If one of the catches works, we get the finally too, and then we get the end of the exception. So you can use finally clause without a catch clause, and sometimes you see this. It just says finally, which means you didn't put a catch in there. You threw an IO exception, or you threw in this particular case, a stream exception. Some runtime garbage got printed to the screen, and now finally is going to do some disposal of some objects or something. It's going to clean something up. So sometimes the finally clause can also throw an exception. So we have a search for, and we have a string in here, and we have a word that we're going to search for in the string, and we're going to throw a stream exception. So I create a new object of a stream. We're going to call it input, make it equal to null, try. Some code that's basically going to throw a stream exception. And then finally, input.close. The input.close might throw an IO exception. If you've got if you threw an exception on a stream, maybe there was something wrong with the stream. If there's something wrong with the stream, it's probably not going to close correctly either, which means you're kind of stuck in a situation in which you've got exceptions being thrown everywhere, even in the finally, which is the case. So finally itself, just as a point, can throw an exception. If the try clause throws a stream exception and the finally clause throws an IO exception, the original exception is lost and the IO exception is thrown out instead, a situation you'd better avoid, because then you lose the stream exception. Here's the scenario. You throw an exception. Perfect exception handler, let's say. On the bottom you've got, maybe you put some catches in there, who cares. On the bottom you've got a finally. Finally throws an exception. It's like an interrupt, actually, when an interrupt gets thrown. 1, 2, 3, 4. The last one received is going to be the last one you're dealing with, which is going to be the last one that the runtime environment knows about. All of the other ones that were thrown before it are all gone. So in terms of trying to error check and double check what's going on, you're going to get error messages, exceptions that come out that say something about there being an IO failure, when really it's a stream exception. So, because the last one in the package, or excuse me, the last one in the series is the one that the JVM is aware of. So, believe it or not, that is everything you ever wanted to know about throwing exceptions and exception handling. And the other topic for today, part 2, is the IO package. And the IO package is extremely easy as well, and I'm not going to click on that link to check out the documentation, but the link should work. If we import java.io, we get a bunch of packages that deal with reading and writing and input and output of files. So, you're back. Alright, so the package defines I/O in terms of streams. We have ordered sequences of data that have a source, an input stream, or a destination, an output stream. So stream data is sort of like buffered I/O in the C++ days, I guess, versus a low-level read and write in terms of input-output. So 2 parts. We have a bit stream and we have a character stream. The bit stream is an 8-bit data-based. Input streams and output streams are of type bytes. And then we also have readers and writers that are characters. And we have different methods that we use to create a reader or a writer when we're working with characters, or input or output streams. So a stream is at a byte level. We don't have as much control over the string quality or over the stream itself than we do as a character stream. So a character stream is actually an extension on a stream that creates more facilities for reading and writing. As an example, if you know you have characters in a stream, you can look for particular characters like line return, end of file. You can look at delimiting characters for, say, commas or spaces or something. You can do a lot more when you're dealing with essential, string processing from a character level versus a byte level. So. And it's not really, you can't really compare this to bytes by byte reading versus line by line in C++. If you're familiar with any of the I/O stream, or the stream type interfaces with C++, there's a lot of different libraries set up to do different types of manipulation on it. Some of them, the method, or what we call the method called function calls, read byte by byte. Some do line by line. Some do the entire stream. Not to be confused, it's kind of different hierarchical level, but they're all pretty much doing the same thing. So they're all reading essentially byte by byte, or however it is you specify it. So we have 2 parent abstract classes. We have input stream and output stream. And so in terms of the reading of the bytes, to separate this out into byte to character. In the byte category, the input stream class defines an abstract method, as you would probably imagine, called read. Read throws I/O exception. Pretty simple. The designer of the concrete input class overwrites this method to provide useful functionality for the type of read that you'd like to perform. How do you want to read it? So as an example, in the file input stream class, which is implemented on this abstract class read, you're never going to run a read method. You're going to run one of the implemented classes that are built on this abstract class. We have a method that reads 1 byte from a file, 1 byte at a time. And there's reasons why you want to read 1 byte at a time versus 1 word at a time versus 1 line, etc. So we have different input file streams and different methods that we're going to run that's basically going to be built on the abstract read concept. Input stream class also contains non-abstract methods to read an array of bytes or skip a number of bytes. Like, give me every 5 bytes of every line. So you're getting, for example, the first column of something in a text file or in an input stream. So although it's abstract, we have implementation that helps us automate the read concept. In terms of writing, we have the output stream class, the same as the input stream class that defines the abstract method. And then in here we have write. So write something. So throws an I/O exception. Output class also contains abstract methods for tasks such as writing, and the implementation is there for, let's say, for a specific byte array. So we close the stream after reading it. It's like doing an open and doing a close, which is the same thing you get in other languages. And it frees up the operating system resources, closes the file, writes the, make sure you're not going to get any issues in terms of the file corruption, anything happening with the file. And you might imagine that this is probably a little bit more simple than a C or C++ file I/O. In C++, if you're familiar with it, you usually have to create a file pointer. You open up the file, you process the information through the file pointer, and you end up having to do a lot of low-level kind of instruction to check to see if they have the end of the file, or the end of the stream has occurred, check to see, then load it up manually into a stream instead of just creating a stream from the file. And a bunch of manual effort. This is more automated, I would say. The file I/O facilities in Java is extremely easy compared to some other languages. So here's a sample program code here. We're going to count the bytes. We're going to count the bytes in a stream. So we have Java IO, and here we have a void main. It's going to throw IO exception. And in file input stream is going to read a file in. It's going to be called in. It's going to be a new file input with the arguments of the file that we're going to send. We're going to catch from main. So when we run this code, count bytes space the name of the file. And the argument is going to come in as the name of the file. The total byte is equal to 0. Set the total to equal to 0. We're going to keep a count as we go through. While in.read, which is one of the concepts you have, you don't actually have to check for the end of file. You don't have to check for anything. You just go, well, while we can read, well, in.read, read every bit of the file, byte by byte, until if it doesn't equal -1, which would be an error on read, it can't read it. So it's going to come back 0 if it's successful. Total, plus, plus. Close it, essentially, and then print it out total bytes as bytes. Print out the total bytes. Pretty simple, which kind of demonstrates the point that I'm trying to make in terms of how easy it is in Java versus some of the languages. And here's another example here. Let's say translate the byte, where we can say same code as before, but we're reading it in, and we're saying the character at this particular byte, and we're casting the object type to byte. So we're saying the character at this one, do something with it. So it's going to take it and, I don't know, this is going to essentially integer x. It's going to do some manipulation to the character at a particular level. So to run a Java translate B to B, oh I see, it's taking the argument to, so we got argument, oh here we got argument 1 and argument 2 going on here. It's taking the B and changing it to B, smaller to capital, and then entering in big boy via the keyboard is going to be changing the lowercase to higher case, or just the, actually it's just taking the B's, it looks like. So in this particular example, if we gave it BB. So character streams, that was the byte stream, and the byte stream didn't look at it as a character, although we took it as a character. We took the byte and did character at. So just because you're reading it in as a byte doesn't mean you can't use it as a character. But if you're going to use a stream, a character string, in terms of a string, you're going to want to probably use the character stream instead, because you have a few bit more different methods to work with character data versus just generic byte data. So you might say that the character streams is kind of a higher level implementation of an abstract byte concept. So, two parent abstract classes for characters, the reader and the writer. So it's kind of like read and write again from a byte perspective. Each supports similar methods to those in the byte stream counterpart, input stream and output stream respectively. Standard streams, standard system in, system out, and system error exist before the invention. So this is a separate class actually, and this is standard in system.in.println system.out.println to print something to the screen. The system.in to get keyboard information is an implementation on a stream concept, which is actually sort of in a separate class of itself, or a separate object, because it existed before. But they have byte stream through logically. Although logically they should be character streams, they're actually implemented on the byte stream class, is what the slide is trying to tell you, which is they're using the stream input, file input stream, file output stream, and they're writing it to standard output, which is going to be your monitor essentially. Could be used to write to file as well, or to error. In fact, the IO exception is using a system.error. It's taking that. So in there you can go system.error and write to the error. Essentially add your own information to the error log as well. So conversion between the byte and the character stream. Let's take a look at this for a second. The conversion streams input stream reader and output stream reader translates between Unicode and byte stream. And we have the class methods input stream reader that takes in a reader or a string encoding. So we have the string itself, the input, or we have the encoding that we're going to do for it. Whether it's Unicode, what type of encoding, what type of ASCII character set or whatever happens to be associated with it. And then we have the same associated methods for the out, so we can specify it. So the read method of the input stream reader reads bytes from their associated input stream, converts them to the characters using the appropriate encoding for that particular string. So you can change the character set or the encoding method essentially by using the read you specify which one to read it with. Or the write, which is going to do the opposite. Take the supplied characters and then convert the bytes using the appropriate encoding. Write them to the associated output stream using the correct encoding that's specified by the method. And then closing the conversion string also closes the associated byte stream. But not always desirable. If you have a byte stream that you want to keep, you would probably want to make a backup copy of it before you closed it, because closing one is going to close the other one automatically. You might want to go back to it. So let's talk about working with files for a few minutes. Sequential access files or random access files. In a C environment, when you open a file, you generally have to say, is it going to be for reading, for writing? Is it going to be random access? Is it going to be sequential access? You have to give all that stuff to it. Instead, in Java, you actually perform a particular method call on it, on the stream, and to kind of figure out what method you want to use in terms of the functionality of how you want to treat that particular file. So sequential access files, the file stream, the file input stream, the output stream, file reader, file access, allows you to treat the stream as input or output sequentially. So each file stream type has 3 types of constructors. So when you make the object of the file stream, if I said that correctly, the file input stream, output stream, or any one of these other methods, you call the constructor of the type that you're interested in using. So that's the constructor that takes a string, which is the name of the file, just a default, which is going to be essentially a sequential access file format that you're going to be reading it with, or a constructor that takes the file as an object with a reference to the file, or a constructor that takes the file descriptor object. As I mentioned before, in C or C++, we create this thing called a file descriptor, which is really a pointer. And that pointer is pointing to the memory that's associated with the open file. We do that, and that's implemented in a lower level kind of language like that, because it's really time consuming to go out to the disk and read from the hard drive or read from the particular storage area. Secondary storage is very slow, it's very time consuming. So the file descriptor goes out, finds it, all the bytes associated with the file, and creates the abstraction of memory, and then we read from the memory. And then the file on the disk stays the same. We don't touch it. We don't go back and try to do I/O reads to that, which is kind of slow. Believe it or not, the same actual concept exists. In Java, it's just implemented for you. We don't have pointers in Java. Instead, all of the implementation of all of the particular things that would use a pointer in that concept is done for you. So you never have to worry about creating a file descriptor, but you can use a file descriptor concept. If you're doing that, you're inputting a sequential access from the file through the descriptor. You're saying, I'm going to read it this way. The random access allows you to read and write data beginning at a specific location. So it's going to pre-read, process, and index everything and say, well, from this particular location inside of this particular file, go to the 10th line or go to the 7th line and then read this information or something. So we have a file pointer that's used to guide the starting position. Again, we don't have pointers in Java, but this is done to a file descriptor that's implemented for us. We use the pointer as index, if you want to call it that. So it's not a subclass of the input or the output reader or the writer, because it supports both input and output, and both bytes and characters. Actually, the random access file can do bytes or characters. It can essentially accomplish everything all in one. Here's an example of the random access file, and we're taking and this is going to be a file copy. This is essentially going to copy one file to another copy. And then we're implementing some tries in here too, and some catches, and we have we have 2 tries going on, one right after the other. One is if we can't open a file, if we can't close the file, we can't write the file. So we have file number 1, file number 2, and we're going to take file number 1, random access. We're going to try to open it using a read, and then the next one we're going to do a read-write on it because we want to open it up. We're going to write, and we're actually going to take it all at one time, and then the other one's going to say, if the buffer is having problems writing it out, we're going to catch that exception as well. So we essentially have I/O exceptions going on as well in this particular example. and printing out an I/O error occurred if we catch it, kind of thing. So, and here's a file not found if we can't find the two files. So it kind of demonstrates both concepts that I've been talking about today. And you can cut and paste and put this in. It should be compilable code. It should work for you just fine. We have the file class. The file class is particularly useful for retrieving information about a file or a directory from the disk. We don't use the file class to actually open the files, which is interesting. We can't get any information from the file descriptor. Instead, we create an instance of an object that represents a file, and then we ask questions about the properties or we set properties of the object. So a file object actually represents a path, not necessarily the underlying file, but maybe the path to the file. And it does not open or provide any file processing capabilities. It just represents the file. So we can have, there's a file chooser class that's built on top of the file class. And the file chooser allows us to look at the contents of our hard drive, and sort of like a file manager. It allows us to kind of bring up all of the potential files that we might want to be using and get some information about the files. Really all we can get from a file chooser method, or excuse me, object that's created, and I'm going to go through file chooser next class actually. Or perhaps maybe the following one, I'm not sure how it fits in the schedule, but we can only get the attributes related to the file, or whatever information happens to be known. So to open and to close it, we got to go back to those previous input streams that we just looked at. There's three constructors to the file object. We have just the name of the file, we have a path in the name of the file, or maybe we have a directory and not the name. And we have the name. So how far back do we want to go, essentially? And then here's some main methods that are associated with it. Is it readable? Is it writable? Can we read it? Can we write it? Does it exist? Is it a file or is it a directory? And what's the absolute path? You know, get the absolute path. Get the parent. What directory is it in? I get the name, get the length, last modified date or something, which is kind of generic file information. We can add more efficiency to this by creating a buffer reader. So the buffer reader reads text from a character input stream, buffering characters, so to provide the efficient reading and writing of those arrays. So buffered reader is equivalent to buffered I/O in C or C++ versus system call I/O. So in C or C++, we have two options. We actually have two options here as well. We can, a low level, they call it a system call read or write, which is not buffered I/O. It's just a manual, open a file, read a byte, open a file, read a byte. The I/O stream actually does perform some low level buffering, but you don't have buffer access. You're really reading it in, holding it temporarily in a stream. And then the stream abstraction is holding the characters that you're reading from the file. So it's kind of a read it in, put it into a stream kind of concept. If you wanted to access it over and over and over again, it's a more effective way not to keep reading it from the file and putting it into a stream, but to buffer it. To buffer it, takes the entire file, puts it up into memory, and calls it a file in memory. So it makes a copy of the file. And then you're constantly reading and writing to the buffer, which again is faster than reading and writing to the I/O. And then you have it available, and the buffer doesn't go away. So you have this concept of the file that's buffered, that's in temporary memory, waiting, and you're accessing it just as if you were accessing the real file. And believe it or not, the method calls are identical. The system, the concept of it is just identical to a character stream, essentially. So we have, in this particular case, this example, we're going to provide a more efficient way of reading arrays of lines. So we have buffer reader, and we're going to read in. We're going to create a reader in. So we're using it along with the reader, the byte stream. We're reading in a byte stream. So to wrap the input stream reader inside the buffer reader, we do a buffer reader in equals a new buffer reader, new input stream reader. So we create a buffer reader from an input stream reader. So we're essentially using both concepts together. We don't use this instead. We use it along with. We say let's buffer it too. We want to create this byte stream input, and we're going to buffer it. So you can use one without the other. You don't have to always use the buffering one. Depends on what you're going to use it for. So to wrap the file reader inside of the buffer reader, we have the file reader with the file name that gets put inside of an object that becomes part of the buffer reader. So you can invoke in.readLine to read from the file line by line instead of byte by byte. So you're not reading character or byte at a time, you're reading line at a time. So the buffer reader has, give me the whole thing, find the end of the lines, find the end of the file, go back to the beginning of the file, all these methods to manipulate it as a whole file, essentially, as a buffered file. Here's an example of the efficient reader that reads it in, and it's only done for efficiency and for automation. You can accomplish the same things with this, with all of the other objects that we've looked at so far for the byte stream and the character stream. You can accomplish the same things, but it's more lines of code. So this lowers the lines of code, automates it by buffering it. So we have a buffered reader, BR. It's going to be a new one from a file reader. Read the file in, get the line, strings into a br.readLine, process the line. Well, it's not the end of the file. We're going to do something with it. We're going to read it, print it to the screen, and we're going to close it. And then we're going to throw all these exceptions at the end. The exceptions are the same. IO exception, file not found exception, the ones we've been looking at so far. Additional reading material, if you're so inclined. I'm not going to click on these links. Last time I checked, actually I checked for the weekend course, and the links worked. All the links work. So, and great examples for reading and writing. Great ones for accessing file permissions and file access rights as well, which you might find helpful depending upon what your goal is. So that was what I wanted to accomplish for today. Next week, maybe I'll do it next week actually. Let me take a look real quick. We have a few minutes. Get rid of Lecture 7, take a look at Lecture 8. I believe we're going to start looking at the GUI swing component. Swing, yes. Next week, we get into user interface components with swing. And swing is all about fun stuff. And that one is the next programming assignment on the agenda, which I believe is number 3, but let me just check real quick. It's the one that does the notepad, Java pad assignment. You're going to create a notepad program, and don't freak out. I'm actually going to give you the code for it. Nope, hash map is number 3. That's the one we just did last week. So it's really a 2-week sort of lecture, this one here. If you want to get started on it, number 4, look at the video tutorial that is with the assignment description that's on the bhacker.com website. I build everything for you except for the style menu. And it actually might prove to be a beneficial exercise to go through. But next week I'll start in with the swing components and look at the AWT Abstract Window Toolkit, swing, the differences between the two components and all the theory part of it. And then the following week I'll go through the assignment and go through some GUI examples and stuff. This is what I call the fun stuff, actually. I don't know, IO exception handling, that's something really entertaining, that's not really fun, but working with GUI stuff, that's fun. User interface stuff, it ends up being fun. So unless we have any questions, comments, or concerns, we are done for today. Oh, we end early today, for once. Oh yes, we do have a comment. Yes? I'm actually putting that together. I have not finished it yet. What I'm going to do is put it out. Let's see, do we have web access? Are you saying it's down? Still down? Well, I have to put it together for these guys, and I'm going to be doing it probably tonight or tomorrow. And what I'm going to do is put together an outline and put it in a Word document, and I'm going to put it out there and say final exam review for weekend exam on the 29th and 30th. And what I'm going to hopefully do is just outline everything you need to know for it. But again, just so you know ahead of time, it's going to be multiple choice types of questions. I'm going to tell you in the review which PPTs to actually go through as well. So that would be out. Well, I was going to actually work on it today, but because I have it half finished, I can't upload it, probably not till this evening. So when it's probably later tonight, tomorrow, you might see it actually, and then I'll have the TA. I'll have a TA send it out to both sections. She's probably just going to send it out to the weekend section normally, but because they're the ones who are taking the exam. But I want to extend the offer out as well, because some people who aren't sitting here don't know that they can actually have that option of taking that exam. So a lot of people like to take exams early, get it out of the way. That's a choice you have. So. But yeah, no, look for it later tonight. Long story short. Any other good questions? That's a good question. I should have mentioned it. So. No? Then we're done. Enjoy the internet. Is there class next week? The Volley Festival next week. Here, let me shut off the video because these guys